Hey guys, how's it going? I speeded up the JRE once more, and this time I made it faster when you're trying to push bytes from a socket to a file. What is the difference between my older contributions, which also dealt with transfers and files, to my latest contribution in JDK 21? Well, let's look into the source code and you will understand easily. Let me expand a bit this code so you would better see where we are. We are inside of the input streams transfer to method, and as you know, I already did several contributions and optimizations. We're not talking about those today. You can find it in my older videos, but to understand it, it's necessary to take a quick look. What we did in the original contribution was to speed up transfers from file to file. Then we extended it for transfers where the file is the source, so we can push data very quickly from a file to, for example, a network card without going through the memory of the Java virtual machine. This time we're doing the opposite. I have added this source code which actually checks whether we are going to a file. So we're coming from somewhere, like a network card, for example, and we want to push bytes into a file. And what we're doing essentially is calling this method. I'm skipping the explanation of this code because that is already found in my older contributions. It's just a safety means. Check the old video and you will find an in-depth explanation. And here you can see what we're doing actually. We want to transfer bytes from a readable file channel to from a readable byte channel to a file channel. And what is the best way to do that? You could imagine several ways, and we want to provide the optimum way with regard to performance. And the optimum way is to tell the file channel that it shall transfer bytes on its own from another source, which is given here. So we tell the file channel transfer bytes from the source starting at the initial position. The initial position is queried by DST position, and we try to move as much as we can in a single batch, and certainly we will transfer fewer bytes. So we get here the number of transfer bytes, and when the number of transfer bytes is larger than 0, then we sum it up and we start another turn. So in case we're not able to transfer all the bytes in a single shot, we will have more iterations until transfer from gives us a -1 and tells us we're at the end of the file, and then we're done. And what we do then is we tell the file channel that we're at the new position. So if someone else wants to write in that file, he will find a pointer pointing to the actual end. So then we return the actual bytes transferred, which is the start, which is the current position minus the starting position. So this is not really rocket science, but it's the fastest way you can transfer bytes from any arbitrary channel to a file channel. So there's not more actually. There's a test for it. Certainly, if you want to check out the test, it just uses the existing methods and extends them a bit. It's no rocket science either. So that's it. Actually, that's my latest contribution. And what it does is it's optimizing the performance. Whenever you are receiving files, for example, a client does an upload on a web page and the web page wants to store the uploaded file on a local disk. And you're sparing going through the JVM's memory simply by telling the operating system, do that work for me. So the JVM is not doing anything on its own. And the operating system is much faster than the Java virtual machine. That's it. I hope you liked this video and give it a thumbs up or become a subscriber. So until next time, stay safe and party on.